This video is the second episode in the FluxTools series, where we'll dive deep into the Redux model. Redux is an adapter for all Flux.1 base models for image variation generation. Functionally, it's very similar to IPAdapter. The example above shows a breakfast image as input, generating multiple results with similar styles but different compositions, without using any prompts. In the example below, Redux is paired with prompts to alter the style or subject of the input image. It looks cool, but how accurate are the results? Let's find out. The Redux model is a small file, just 129 megabytes. Once downloaded, place it in the models/style_models directory. As discussed in the last video, Comfy UI natively supports all FluxTools features right out of the box. So let's open Comfy UI. We won't install any additional plugins and will use the built-in nodes instead. Load the official workflow. The bottom section is the familiar Flux text-to-image workflow, which you can tweak based on your preferences, such as sampling methods or steps. The top section consists of new nodes used to load and apply Redux. We've previously mentioned that although Redux and IPAdapter both provide image references, they function differently. IPAdapter modifies the model to reference the input image during generation, while Redux uses clip vision to convert the image into a prompt, which is appended to the positive prompt and passed to the model for generation. Let's start by inputting an image of a dog wearing a hat. For the clip vision model, use Google's SIGLIP SO 400M patch 14-384. However, if you want a smaller alternative, you can download SIGCLIP_vision_patch 14-384, which works just as well with Redux. Before clicking Run, select the Flux image generation model, clip, and VAE within the text-to-image workflow. Since file paths and names may vary locally, make sure to configure them correctly. I'll also switch the base model and clip to their FP8 versions. For now, I'll leave the positive prompt blank. Let's click Run to see how Flux generates results using only the image reference processed by Redux. The results are in. Let's zoom in and compare. The generated image features a similarly melancholic dog, a hat, and a red sofa, almost identical to the reference. When using IPAdapter, we learned, and most of you likely know, that clip only accepts square images by default. Previously, we addressed this with the prep image for clip vision node. But how does Redux handle this? Let's switch to a vertical image as the reference, a woman holding balloons. Without changing any other settings, run the workflow. The overall similarity is decent. It retains the woman, balloons, backless dress, and snowy background. However, the image isn't complete, as it only preserves the center of the reference image. That's because the clip vision encode node defaults to center cropping for non-square images, extracting only the central area. Now, let's change the setting to none, fix the seed, and add a preview image node. Run the workflow again, and you'll notice that the new image includes the full reference image without cropping. However, this node uses bicubic interpolation to convert non-square images into square ones. If the aspect ratio difference is too large, significant information may be lost, and you might encounter overshoot issues, values outside the range of 0 to 255, which can sometimes result in suboptimal outcomes. To better demonstrate the next features, I'll switch back to a square reference image and use center mode. Then run the workflow again. We've mentioned Redux strong image interpretation abilities, but you may not yet have a clear sense of this. Next, I'll compare it with a commonly used reverse prompting tool to show you the difference. Add the Florence 2 Run node, which is easy to install, along with the required model node. Select the model Florence 2 base prompt gen v2.0. Set the task to more_detailed_caption, and connect its output to the Flux text-to-image workflow while disabling the Redux process. Then, duplicate an image node for comparison and add a text display node to view the generated prompts. Click Run and check the text. It's incredibly detailed and comprehensive. Now examine the Flux-generated image based on these prompts. It includes balloons, the figure, and a snowy background. However, the positioning is slightly off. Let's try combining it with ControlNet. Clean up the workflow and add a LoRa load model-only node. Select the depth LoRa from FluxTools and integrate it into the workflow. Next, add an instruct pix-to-pix conditioning node to apply the ControlNet model. Since depth requires preprocessing, I'll use the depth anything preprocessor, which we've previously identified as the best choice. Finally, add 2 image nodes to compare the preprocessed results and the final output. Click Run. With reverse prompts and depth ControlNet combined, the structure aligns more closely with the reference, but it lacks the same essence and detail. Redux still performs better overall. Some might wonder if Redux works with the GGUF version of Flux's base models for those with limited VRAM. The answer is yes. Let me demonstrate. Delete the unused nodes and tidy up the workflow. Add a UNetLoader, GGUF, node. Select the FluxGUF Q8 model, replacing the previous FP8 model. Enable the Redux workflow, and click Run. The results are almost identical to before. Some users prefer the faster Schnell model, which also works with Redux. Delete the GGUF node just added and replace it with the Schnell FP8 model. Reduce the iteration steps to 4, add an image node, and run the workflow. Redux clearly guides the image generation, but the output quality is slightly inferior to the dev model. There are now many unofficial fine-tuned versions of the Flux model that perform well. For example, PixelWave. Replace the model with PixelWave, set the iteration steps back to 20. Add an image node to record the output, and click Run. Redux continues to perform impressively. Redux' ability to replicate the original image is undeniable, but referencing an image isn't just about replication. With IPAdapter, for instance, we often pair it with prompts to make modifications, like changing the style. How can Redux achieve this? Delete the unused nodes and switch the model back to dev FP8. In the prompt, write pen and ink sketch to see if it can generate a pen and ink style drawing. After running, while the image has changed slightly, it doesn't exhibit the pen and ink style at all. Could it be that the prompt weight is insufficient? Increase it to 1.5 and run again. Still no success. If increasing the prompt weight doesn't work, the next step is to reduce Redux strength. Lower the strength from 1 to 0.15. And the image changes significantly, but the style still doesn't match. Reduce it further to 0.1. And while the style now aligns, the resemblance to the original image is gone. Let me show you the comparison images I generated with code. None of them are entirely satisfactory. There's always a trade-off between the art style and the original image details. This is because the native nodes simply multiply the strength with the Redux prompts, making control difficult. If you need this functionality, I recommend using the Advanced Reflux Control plugin. This plugin can be installed via the manager, and its dependencies are minimal. Don't forget to restart Comfy UI after installation. Add the Style Model Apply Simple node. Its parameters and connections are almost identical to the native node. The strength has 5 levels, keep it at the default medium. At this level, the prompt takes effect without needing additional weight. Add an image node to display the result. Run the workflow. And the output retains the composition and content of the original image while switching to the specified style from the prompt. I won't demonstrate all the strength levels one by one, instead, here are the outputs. Generally, when using prompts, LoRa, or ControlNet for modifications, it's best to choose medium or lower strength levels. At the highest strength, the results are similar to the native node with strength set to 1, meaning little to no modification is applied. This plugin also includes a more powerful node, Redux Advanced, which offers additional functionality. Let me show you how to use it. Replace the connections from the basic node. As you can see, it accepts direct image input, so the Clip Vision node is no longer necessary. Delete it and tidy up the workflow. Run with the default settings. And the results are identical to the basic Style Model Apply Simple node. Once you learn how to use this advanced node, you can completely replace the basic node. Let's take a closer look at its parameters. Downsampling factor, this ranges from 1 to 9. Values 1 to 5 correspond to the 5 levels of the basic model, where 1 is the highest and 5 is the lowest. Values 6 to 9 offer even lower reference levels. Downsampling function, this determines the interpolation algorithm used, with area as the default. Other options like bicubic and nearest_exact also perform well. Experimenting with this can significantly impact results. Mode defines how the image is cropped. Options include center, crops the center of the image. Keep aspect ratio, maintains the original aspect ratio. Auto crop with mask, works exclusively with masks. It centers on the mask, crops a bounding box based on the autocrop_margin, and scales it to the desired size. Weight, adjusts the strength, but unlike the native node, it squares the value, applies the weight twice. I recommend prioritizing downsampling factor adjustments and fine-tuning with weight as needed. Now, let me demonstrate some of its advanced applications, such as referencing only parts of an image. Upload an illustration of a sheep holding a balloon, exploring the city. The overall image is great, but I only want to reference the sheep. How can this be done? Right-click on the image, select Open in Mask Editor, and apply a large mask over the entire sheep. Save it to the node. Note that this usage might feel counterintuitive. The mask doesn't block Redux, but instead specifies the area Redux should reference. Keep the strength at 3, and set the mode to keep aspect ratio, which will scale the mask and the original image together to the specified size, 384 by 384, and only reference the resized mask area. Alternatively, you could select Auto Crop with Mask, which centers the reference on the mask and creates a square area around it, with the mask occupying a larger proportion. Connect the mask to the mask input of the advanced node, add a preview image and preview mask node. And set the prompt to a lady. Click Run. The result is a white-haired lady with a top hat, holding a string. As for why there's no balloon, it wasn't included in the mask, so the model didn't reference it. Now, I want the generated image to be closer to the reference. Set downsampling underscore factor to 1, highest, and click Run. Oh no! While the image does resemble the reference more closely, it looks a bit blurry. What to do? As previously mentioned, for major adjustments, change downsampling underscore factor. For minor adjustments, tweak weight. Reduce the weight from 1 to 0.5 and run again. Much better. The sheep lady in the striped shirt now appears clearly in the generated image. Can it reference an even smaller area? Of course. Clear the previous mask. And this time mask only the MIE on the sheep's body. When the mask area is small, and you're using keep aspect ratio instead of auto crop with mask, it's recommended to increase the reference strength. Set the weight back to 1 and click Run. Success! A lady in an orange outfit with MIE on it has been generated. IPAdapter allows multiple image references, and Redux can do the same. The node in the Comfy UI workflow explains this clearly. You can reuse the Apply Style Model node. In our current workflow, just add more Redux Advanced nodes. Duplicate a Redux Advanced node, complete the connections, and add a new Upload Image node. Select the dog with a hat from earlier. And replace the other image with an owl perched on a branch. Since we aren't using masks now, disconnect the mask connections to avoid errors. Set both images downsampling underscore factor to 1 and clear the prompt. Run the workflow. The result? A cute hybrid, a dog-owl. However, with this simple workflow, the generated creature isn't stable. Change the seed, and it might become an owl dog instead. Next, I'll demonstrate how to use masks to merge specific areas from two images. Replace the dog image with a patterned background. Add a segmentation node, layer mask, segment anything Ultra V2. To extract the owl's subject mask and connect it to the Redux node processing the owl image. This ensures that only the owl's subject is referenced in the final image. Then, invert the mask and connect it to the Redux node processing the background, so only the background, not the subject, is referenced. Click Run. And now the generated image has the owl in the foreground and the patterned background. This is how you reference specific regions from two different images. Did you get it? We've covered the basics, so let's look at a few popular use cases. First, let's see how Redux handles one-click outfit changes. Upload an image of a red dress as the clothing reference. Remove the second image and its associated Redux node. And keep the segmentation node. Since we'll need a prompt for this workflow, set downsampling underscore factor to 3, and write a simple prompt like a lady. Run the workflow. The result matches the general idea, but the dress doesn't look exactly like the reference. Lower downsampling underscore factor to 2 and try again. While it's better than before, it's still not perfect. Perhaps it works better with simpler clothing. This dress might be too challenging, so let's not be too critical. Here's my understanding. Redux ensures the generated image strongly references the original outfit but lacks the ability to adjust poses or angles effectively, making its integration with the model somewhat average. In comparison, CatVTON is specifically trained for virtual try-on tasks and performs better in terms of clothing accuracy and fit, though its output quality is slightly inferior. I'm looking forward to the upcoming CatVTON LoRa model, based on FluxFill. Redux performs better in e-commerce product workflows. Load an updated workflow I've prepared, and zoom in to see the Redux section. It's paired with Canny ControlNet, which ensures the product's shape remains consistent. Replace the previous inpainting sections. The rest of the workflow remains unchanged, with the prompt only describing the background and atmosphere. Click Run. This workflow takes quite some time, so I'll speed it up. The far left result is the direct output from Redux. It is reasonable composition without black edges or artifacts, but the product details are lacking. After lighting adjustments, inpainting, detail restoration, and color correction, the final image looks decent. I haven't tested many product images, this is just an example. Feel free to experiment and make adjustments. Let me know if you encounter any issues. Many people may wonder if Redux can replicate IPAdapter's functionalities, like composition or style transfer. These features in IPAdapter were the result of the plugin author Cubic experimenting and summarizing how different unit layers function, providing multiple options. However, such functionality might not be possible with Redux. I've also tested a few open-source Flux IPAdapter models, but the results are not ideal, sometimes even worse than RF inversion using reverse sampling techniques. Cubic is pessimistic, suggesting that unless Black Forest Labs steps in, a robust Flux IPAdapter might be out of reach. There's a saying, the camera wasn't defeated by better cameras, but by the ubiquity of smartphones. Perhaps in the Flux ecosystem, we won't get a better IPAdapter. Instead, we'll rely on more Redux-like models. That's all for today's video. You can find the models, plugins, and workflows in the description. See you next time.